Disclaimer: this program is not intended for JavaScript developers. We teach real programming languages, not work miracles. Salutations. I'm Jesco. You're watching Game Dev Made Easy, and the video for today is a Unity-specific video that will be about creating a multi-monitor display for a single game. What I mean by this is take a look at Nintendo DS, the old punch-out arcade cabinet, or the Nintendo 3DS for how a single game can utilize multiple monitors to display information on one screen and the actual gameplay on another. This is actually a recreation of an old video with a much better PC setup and more in-depth information. A viewer of mine actually asked me about the video, and this is what spawned the idea to revisit that old video and give a better example of what is happening. Before we get into it, we first need to understand exactly what we will be doing and how to go about implementing it. Multi-monitor displays refer to having more than one monitor being displayed to simultaneously while being able to directly control output on one or both monitors. Generally, in games that incorporate the usage of multi-display monitor modes, what happens is useful information is displayed in either the top or the bottom monitor. Generally the bottom, and the actual gameplay occurs in the opposite monitor, generally the top monitor. Now with PCs, the configuration varies greatly. Some people might have a setup that has a stacked monitor setup, and others will have a configuration where monitors are side by side. And this is just taking a dual monitor configuration into account. With all this out of the way, let's cue the intro, animation, and music. I have already created an empty project, as we can see here, and Unity already has everything set up for a sample scene. We will go ahead and expand upon this to build this project. Now the first thing we need to do is create a secondary camera. We need to change the camera mode to be orthographic and set the display to be display 2. The reason for this is we want this display to not only show up on a secondary screen and not the main display and be drawn over by the main camera. The next item on the list is to change the camera's position to be absurdly out of range of anything that could be on the screen at any given time. The X position will be 425439, the Y position will be 16713, and the Z position will be at -5.45. This is so no items or effects will bleed over into the secondary screen unless you want it to. Next up, we want to create a canvas for it to be a child of the secondary camera. This is purely for organizational reasons. The canvas should be set to render mode, screen space, camera, and make sure the render camera is the secondary camera. We don't want this to be drawn on the main camera at all. Create a panel to be a child of the canvas. So this is so we have the option to make the background color to be different from the main camera's render view. We can change the color if we want by changing the panel's color to be a solid value for whatever you want. Next up, create 4 buttons and set them to be the child of the panel. The text of each button should be drop cylinders, drop capsules, drop cubes, and drop spheres respectively. This is just so the organization just to organize and be able to know what each button is supposed to do in the scenario. Page fucking 2. The next step is create a prefabs folder. In the hierarchy pane, create a cube, capsule, cylinder, and sphere. Make sure all of them have the rigid body component attached to them. We want gravity to affect them. This will be important later. Drag and drop the cube, capsule, cylinder, and sphere into the prefabs folder and delete them from the hierarchy pane. Let's create our scripts folder next. The 3 scripts we will create will be destroy by time, drop scripts, and multi-display code. We are going to utilize all of these very soon. As you can see, each of them have been named according to what their purpose should be. Drag and drop the multi-display code script onto the main camera. We could create an empty game object to be our manager item, but we don't really need it for something like this. On the secondary camera, drag and drop the drop scripts into it. The last thing we need to do in the editor for now is go into our prefabs folder and left click on the cube we created, click on add component. Highlight scripts and select the destroy by time script and add the script to the prefab. We will do this for the capsule, cylinder, and sphere as well. Now double click on the multi-display code script to open it up in Visual Studio. Transition. Delete the comments and the update function from the multi-displays code script. We only need the start method, so we don't really need to have the superfluous code and comments remaining there. We will create a for loop within the start method. For int I is set to 0, I is less than the display.displays.length I plus I. I plus plus. What the fuck ever. This for loop will loop through all of the active displays that are available on the system. Write display.displays bracket I.activate. This will make sure the displays we have available are now activated if they are needed. This is all we need to do in the multi-display code script. Let's move over to the destroy by time script to get that out of the way. Delete the comments and update function from this class as well. Again, redundant comments, that code isn't needed here. Above the start method, write public float lifetime is set to 1.5 float. This will designate how long we want the objects to stay alive in the hierarchy pane for in-game. Inside of the start method, write destroy parenthesis game object comma lifetime. This will remove the game object by the time we specified. That completes the destroy by time script. Now we can move on to the final script, which is a drop script. Delete the start method, comments, and update method. None of this will be used at all. The first thing we need to do is to create a public list of game objects called drop items. This will house the sphere, cylinder, capsule, and cube from within the editor. Write private void drop item with the parameters set to be string name. We are creating this method to do all of the legwork, but allow us to call it in public methods with the same name of the item we want to use. Fucking third page. To put it bluntly, it follows the dry and kiss principles, which is don't repeat yourself and keep it simple stupid. Next up, create a var called xminmax, and it will be set to random dot range with the parameters being -10 and +10. This will set the horizontal axis to have a specific range that the items will be able to spawn in. Vector 3 spawn position is the next thing to write, and that will be set to a new vector 3 value of xminmax, 10 and 0 float. This will be the vector position we will utilize for the spawn game objects. Quaternon spawn rotation is set to quaternon.identify. This is for the rotation of our spawned game objects to be set to the identity of the game objects, which just means the rotation is set to 1. Why the fuck didn't you say that? Next on the list is create a for each loop. For each var item and drop item is what we will write. We are iterating through all of the game objects within the lists we created. Inside of the for each loop, we will create an if statement. If the item dot name is equal to the name, we want to single out a specific item from within that list, which will be evident why the steps following this method. Inside of that is if statement, right? For int I is set to 0. If I is less than 100, I plus plus. We want to create 100 of the item in question, but you can change the value to be whatever you want it to be. Inside of the for loop, right, instantiate item, comma, spawn position, comma, spawn rotation, and now we whatever the fuck that word is, the items to actually be called in game. This completes the drop item method. This method handles the creation and selection background code that we need to have game objects spawn in the game. Now we will create our next method, public void drop sphere. This will be called by the button press of the drop sphere button. Inside of this method, write drop item with the string value of sphere being the parameter. Next up, we will create a public void drop cylinder method as you guessed, it will be called by the drop cylinder button. Write drop item with the string value of cylinder as the parameter. The third one is public void drop cube. Inside, write drop item with the string parameter being cube. And the final one is public. Yeah, enjoy that. Void drop capsule. Inside, write drop item with the string parameter being capsule. You can now see exactly why we had the drop item method to have the string name parameter and the check for the item's name being equal to name. This drastically reduces the amount of code we would have to write and allows for us to make modifications for more items to change the items and whatever the fuck. This is something you should always think about when writing any code. If you find yourself repeating something, there is smell in your code and you should rectify that as quickly as possible. This is a fucking 4th page problem that many beginners and a problem that programmers that don't think about proper coding conventions when writing code. Look at it from this perspective if you aren't convinced. The drop item method would have about 7 lines of code without the for each loop or the if check. This method would have to be written 3 more times along with the list becoming individual game objects. In the GitHub repo that will be linked, I will have a script called Bad Way, which will showcase the difference. You will see the same thing being repeated and the total length of 59 lines of code versus the drop script, which has 46 lines of code. Anyways, let's save the script and jump back into the utility editor. Click on the secondary camera and you will see drop items in the drop script. The current size is set to 0. Let's change that size to be 4. Drag and drop the prefabs into the capsule, cube, cylinder, and sphere into the list. This will tie the prefabs to the list and not make the values null. Click on the first button. Click on the plus sign under the on-click option. Drag the secondary camera onto it. Click the functions option, locate drop scripts, and select drop cube. This will make it so that the drop cubes button will drop the cubes. Click on the second button. Do the same thing, only instead of selecting drop cube, select drop sphere. Click on the third button. Do the same steps and select drop sphere. Click on the fourth button, do the same steps, and select Drop Capsule. Click on the file and save in the scene. Now for the final step, click on File, Build Settings. I am building for PC, Mac, and Linux standalone. For this example, select Build. Create a folder called Build and select that folder. Unity will build the project. Once it has finished building, it will open the folder that houses the build files. Now double click on the exe file for the project and select Display to when the dialog box comes up. You can change the display size to be whatever you want it to be and then click to run. We now have a working example of a multi-monitor display enabled Unity game. Yay! This has been Jesco with an update to an older video. If you like this version over the old one, give this video a thumbs up and share it with your friends. I want to give a warm shout out to my patron supporters who have chosen to give me some of their hard-earned money for the content I produce. It means a lot and inspires me to continue to deliver content on YouTube since I don't have the 4,000 watch hours and the 1,000 subscriber count to monetize my videos. Don't ever ask me to do this again.